For homework today, the first thing we're going to do is make a beach ball roll realistically. And in order to do that, we need to open up a world and get a beach ball. So add objects, search gallery, beach ball. And there's the beach ball. Add an instance to the world. There we have it. Now, if you remember in class when we tried to make this roll, we tried a few different things, and it's not intuitive how to make it roll realistically. Try those things on your own. I'm not going to do them all in the video to save a little time here. Instead, I'm going to start off by writing a method called realistic roll. Now, I want to be able to export this as part of the beach ball so that beach balls in the future, if I get the new beach ball that I've made, we'll have that realistic roll method with it. So I'll click beach ball up here, then methods, then create new method, and call it realistic roll. And now I've got my new method. I want realistic roll to receive two parameters so that anybody can call this at any time they include my new modified beach ball class. And the two parameters it's going to get are the distance and the time that it takes to roll. So create new parameter. First one is a number called roll distance. And create another new parameter, which is also a number called roll time. In order to make the beach ball roll, it has to do two things at the same time. It has to spin, and it also has to turn forward. So I'm going to put a do together block up here. And for the moving forward part, I'm going to bring in the beach ball move tile. And what direction? Forward. Amount, we'll say 1 meter for now, but we're going to put in roll, well, we could put in roll distance now. So let's go ahead and put in roll distance. And you may remember we had to make that roll as seen by ground. So I'm going to put as seen by ground. If you don't remember why, don't put as seen by ground in, let it roll and see what happens. And then we're going to also give it a duration of roll time seconds. Okay, that'll take care, well, almost, of the rolling forward. We still have to oh, actually, that will take care of the moving forward. Okay, so but we still have to take care of the turning. So beach ball turn, put that there. And we want to turn forward. Now here's the place where we don't have an expression yet because we need to write a function to figure out how many revolutions. For now, we'll put 1 revolution in there. So it's going to turn forward 1 revolution, and we want to put in a time here. Duration, expressions, roll time. Okay. Let's go ahead and play this and see what happened. Oh, we have to call it yet. So we'll go into my first method and call realistic roll. And we'll make the distance 2 and the roll time 2. That actually looks pretty good, but that's coincidence. It just happened to work out well that way based on the diameter of the beach ball. Try changing the diameter of the beach ball and it won't look so good, especially if you change it dramatically. But we want it to be able to work regardless of what the diameter of the beach ball is and regardless of what the user passed for distances and times. So we're going to now create a function that tells us how many times it should rotate. and that function will be called from realistic roll. So new function, and this function we are going to call rolling revolutions, or yeah, we'll call it rolling revolutions, and it'll tell us how many times the ball should turn around. And rolling revolutions will return a number, so leave number clicked and hit OK. I want to create a parameter, and the parameter will be called distance, and it is a number. So create a parameter called distance. And then what we want to return is distance divided by, so we want to do some math. And we'll put a placeholder in here. We'll say distance divided by 1. But okay, I have here return distance divided by 1, but what I want is distance divided by 2 pi r. 2 pi r is equal to the circumference of the ball. And that tells me, once I take distance and divide it by that, how many revolutions I want to get. And if you're not to the part in math class yet where you get how to calculate the circumference of a circle or the circumference of a ball, you'll get there, and then you'll see why it should be distance divided by 2 pi r. For pi, we'll use the number 3.14. And in order to get twice the radius of the ball, I'm going to use a function called the beach ball's width. So drag that here. Okay, now it's dividing it by the width, but I don't really want it divided by the width. I want it divided by the width times 3.14, which is a value for pi, out to 2 decimal places. Okay, now this function here will return the distance that it's passed, which comes in as a parameter, divided by the width of the beach ball multiplied by pi, which effectively divides the distance by the circumference of the ball. Now that I have that written, I can go back and change my method that I had created earlier to include the rolling revolutions function. So I want to change this to rolling revolutions, expressions, rolling revolutions, and it says distance 1, but I don't want distance 1, I want distance roll distance. So I'm just going to drag roll distance down there where it said 1, and now I should have a realistically rolling ball. Okay, it looks pretty good. It looked pretty good before, but for a good test, let's change the size of the ball and see if it still looks good. Because if you change the size of the ball before we wrote that function and incorporated it, it would have looked really bad. So I'll right-click on this, Methods, Resize, Other. I'll make it 1/4 the size it was, so 0.25. Okay, now the ball is quite a bit smaller. Hit play. And it still looks pretty good as it rolls. And that's it for that part of the homework.